People talk about upgrading skills. It sounds so bureaucratic, like the rhetoric of a government to justify the unemployment rate which is rising. If anybody complains that they lost their job because of the technology, the government of most countries will tell them to upgrade their skills and get back into the job market. It may sound technical, but it's not. It's something that we have been doing in so many areas of our lives without knowing it. Most importantly, we don't call that thing we do upgrading skills. Nonetheless, it is really upgrading skills. Let me illustrate with very pleasurable activity that we all engage in, which is to take photographs. We never have thought how the skills related to photography has changed over the decades. But before I connect this skill upgrading to statistics, I will take a detour into the world of photography so that you can understand the impact of technology and how we unknowingly upgrade our skills. Photography was invented in the mid 19th century, so the first era began in the 1840s up till the 1920s. It's usually referred to early chemistry era. The technology that was used were wet plates and the bulky cameras that we hide our heads in a black cloth, as you must have seen in the movies. In those days, to be a photographer, you had to be good in chemistry and physics. Then, after the 35 millimeter SLR cameras were developed, era 2 of the mechanical film between the 1950s and the 1990s. The skills required shifted from chemistry and physics to mastery in exposure, triangle, aperture and shutter speed control. In those days, only professional craftsmen would be involved in photography still. Then in the 2000s, the technology of entry-level DSLRs and Adobe Photoshop heralded era 3 of early digitals. The skills of manual control of various camera functions were now upgraded to requiring post-processing and data management skills. So now more people could enter photography, but they still had to be good editors and curators. Finally, we come to our times of iPhone Pro Max and mirrorless cameras, which is the era 4 of computational AI photography. Now there is zero technical skills required. You just need to be a visionary storyteller and focus on composition, light theory, moment capture, emotional impact, and so on. So what technology has done is to force us to change our skill set in order to do the same thing, that is to take a photograph. That's basically what upgrading skills mean. So it's not always difficult as we have imagined. It can also be easier. Now, the main objective for me to take this detour in photography is to link you back to statistics, this time descriptive statistics. Earlier, in the days of manual statistics and having to use various softwares like SPSS and Python or even Excel, we needed statistical calculation skills as well as computational skills. But as I have mentioned in the earlier section, with the rise of the fourth industrial revolution fueled by artificial intelligence. Like in the camera analogy, most of what was considered statistics is now automated. What we need now is to learn the skill of how to autopilot. That's a totally different skill set. In this section, I will illustrate how to be the pilot in the era of autopilot in statistics. Let's imagine you are the principal of a school and it has 3 classes. After taking the same test for all 3 of them, you are given the average score and all of them have the same mean. However, you cannot be convinced because you have been receiving feedback that some of the classes are not performing well. Parents have been complaining. They all have a mean of 65, but your intuition tells you that there's something fishy going on. It just doesn't add up. Yet, when you call the teachers at the meeting, nobody speaks up. You can't find a pattern. You can't pinpoint anybody to blame. You have this question in your mind, even though all the 3 classes have got a very good mean of 65. What is it really happening in each of them? How can you find a pattern without having to interview the 300 students one by one? So this is the research question. So you start by collecting the data, which are the mark sheets for all the 3 classes. Each of them have got 100 rows. You try to look at them, but you almost are about to go blind and see nothing but rows and numbers, 300 of them. However, since you are in the era of AI, you put the data that you were given, which most probably was in an Excel sheet, into the AI chatbot. Then you also upload the diagram below. Then you write the prompt to prepare a report as per the format provided based on the data uploaded. So let's say that you get the report as the one below. The next thing to do is interpret it. So like in photography, the skills changed from being a technician to a craftsman to an editor to finally a storyteller. In the era for statistics, the new skill is to be a master diagnostician, like a real doctor, but of statistical reports. So let me illustrate to you how this skill works, how the pilot of the autopilot plane actually flies the plane. So the first skill that you need to have is to read and understand the table of the descriptive statistics outputs. As we have discussed, the mean, which is the single summary number, is 65 for class A, class B, and class C. Then the median, which is the center score. That means that 50% are above that number and 50% are below that number. In the case of class A, you can see that the median is also 65. But in the case of class B, the median is a bit higher at 67. But in class C, the median is much lower at 50. Now, as the principal, you are able to externalize the intuition you had earlier on. But this is the beginning only. More needs to be uncovered through the interpretation skills that we are learning. The third measure is the mode. It is the single most frequent score. Again, for Class A, it's 65. So it's a hat trick. Class A has the same mean, median, and mode. For Class B, it's 67.5, slightly higher. For Class C, it's 20. Ouch! There definitely is something wrong in Class C. But does it mean that Class B is better because it has higher median and mode? The diagnostic skills tell us not to jump to the conclusion yet because there are more measures to investigate. The next measure is skewness. It tells us how symmetrical the data is. That is why the mean and the median differ. You'll be clear about it later on as we use data visualization. For now, let's just continue with the numerical interpretation. In the case of Class A, skewness doesn't exist, it's symmetrical. In the case of Class B, we have a negative skew, that is, the mean is dragged down. In Class C, we have a positive skew, that is, the mean is pulled up. At this point, do not worry. Skewness doesn't make intuitive sense until we can see it visually. But the AI had to give a report, so it did so here. Basically, symmetry is better than non-symmetry. We want to avoid either negative skewness or positive skewness. So, as a principle, you are onto something, and it seems that your gut feelings were right on. Now let's uncover more bad news. Standard deviation, or ST, which is the measure of uniformity and consistency, is around 5 marks in the case of Class A. It's not bad. In fact, it's very good. Most of the students are understanding and performing very similarly. In the case of Class B, the ST is 12. It's not a disaster, but it's definitely a problem. Many of the students are scoring 12 marks more than the mean or 12 marks less than the mean. There's very little uniformity among the students. But Class C has a ST of 25, which is double. Now, you are definitely onto something. This is not right. Your gut starts to twist. What does it even mean that the results of the students fluctuates 25 marks up and 25 marks down? Let's look at the next measure of range. Might give us a better picture still. It tells us the difference between the best and the worst score. In the case of Class A, it's 30. In the case of Class B, it's 70. That's big. And in the case of Class C, it's 80. Even bigger. No wonder the parents were complaining. And obviously, the teachers had every motivation to hide the truth. Then the interquartile range, which is like median, but from upper limit to a lower limit. That represents a range of the middle 50 students. For Class A is 10, Class B is 25, and Class C is 60. At this point, you might not know what the numbers exactly mean, but they're definitely something that's not right. You are more and more certain about it. The hair on your skin is starting to stand up. The AI does the preliminary interpretation for you by providing to you the archetype, which is the immediate strategic label based on the earlier measures and their values. So Class A is classified as a blueprint, meaning an ideal class. Class B is classified as the problem class. And Class C is classified as a time bomb. That's it. As the principal, you've had it. You've decided to call a board meeting and get to the bottom of this. Now you know that there is a problem and you've got a statistical report to prove it, which is based on the very data that the teachers themselves provided to you. But wait, you still need more diagnostic skills in order to defend your arguments in that board meeting. So the second interpretation by AI on what is the true story by the data. In the case of Class A, it says that there is high uniformity and the service of the teaching is predictable and excellent, and the mean is highly representative of the whole class. Story for Class B is that it's a targeted failure. The core base is satisfied, but the negative skew, long tail of low scores, drags the mean down. For Class C, the story is it's a systemic crisis. The positive skew, long tail of high outliers, falsely inflates the mean, hiding the fact that the typical student, median 50, is failing. Do not panic. You will understand what this means after we visit the data visualization in this diagram itself. This leads to the judgment by the AI, which is the strategic invention required and recommended. For Class A, it's a pass or green light. Strategies to maintain and optimize. For Class B, it's yellow light. You've got investigate and further segment and fix the class. For Class C, it's the red light. You've got to declare a crisis because the whole system in that class has failed and needs redesigning. Before you pick that phone up and call for a meeting, let's look at the diagrams which will solidify your diagnostic skills for descriptive statistics in the era of AI statistics. Look at the first diagram. It just shows the three measures, mean, median, and mode, together for the three different classes. In the first diagram, you can see that on the surface, the blueprint class and the problem class A and B respectively seem quite normal, but already class C, which we earlier classified as time bomb, has a very odd shape with different sizes of the bars. Your first red flag. Next, look at the diagram 2, which represents the dispersion or the standard deviation. The first one is for class A, second for B, and third for C. As you can see, the standard deviation that we already talked is increasing class A to B to C, and that's bad. The fluctuation up and below the mean is very high in class B and C. Second red flag. Now we come to the diagnostic skill of understanding and visualizing skewness. Remember, we had a difficult time to understand in the table, but after understanding the graph, it will be very easy. It consists of a bell curve. First one shows class A, the second B, and the third C. As you can see, the first bell curve, it's symmetrical. I want you to take a look at the dashed line, which represents the mean, and the black line, which represents the median. Just notice how in the class A, they are almost superimposed. Then in class B, you'll notice that the median line shifts towards the right. Then in class C, you'll notice that the same median line shifts dramatically towards the left from the mean. This is what caused the skewness. To understand further, you've got to first understand what the bell curve actually tells. So in the x-axis, it tells the score from 0 to 100 here. And in the y-axis, it tells about the density or the frequency. The first bell curve, the peak of the bell or the mountain is right on the mean, which is 65. But the green area is telling that there's an equal number of students who are scoring more than 65 and less than 65. This is called symmetry. Now, the class B is a different story. Median moved to the right, and along with it, the peak of the mountain or bell. What this is showing is that there are lots of people who are scoring high marks in this class, but there are equally lots of people who are scoring low marks, as you can see by the long left tail of yellow that's stretching up to 0. What this graph is telling that the table could not tell is that some of the students have scored 0. In that long Excel sheet of 300 rows, you must have missed that part. But this diagram has made it plain and unavoidable. Now, for class C, because the median shifted to the left, so did the peak of the bell move to the lower grades. What it is telling is that there are more people who are failing than passing. However, anomaly here is that there are some students who are getting 100%, shown by the right tail, which is very long. Again, you could have missed this data as you were scanning through that Excel sheet with the 300 rows. Now, as the principal, you have your third red flag, and a very substantial one. You almost know what is the problem, because you can visualize who are the ones who got the zeros and who are the ones who got the hundreds, and maybe why even. Although this is not what the descriptive statistics is intended to answer or even to probe. Now, your panic has transformed into strategic thinking. Before you get up your chair and storm into the teacher's room, let's learn the last diagnostic skill for descriptive statistics in the form of the box plot diagram. It shows 3 boxes and their whiskers represent class A, B, and C. The dashed line in the middle represents the mean. A dark line in the middle represents the median. And as we have already established in the class A, it almost supersedes with the mean, as shown also in this box plot diagram. For class B, the median is higher than the mean at 67, and in class C, the median is much lower at 54. The length of the box, or the height, should I say, represents the interquartile range or the median range. Early on, we found it difficult to visualize. Basically, what it's saying is that middle 50% of the students an IQR of 10. Then for class B, it's 25, and that's why height of the box is higher. And for class C, it's 7 higher because the IQR is 60. Next, let's talk about the whiskers. Represent first quartile and the fourth quartile. Our education sector, it means third division, first division, second division, and distinction. So in the case of class A, number of students in each division is quite similar. Class B, you have more students in the third division, represented by the whisker at the bottom. Also, there are less students in the distinction division. In class C, something's not right definitely, but there are lots of people in the first division, but equally lots of people in the second and third division. Final component of this box plot diagram are the red dots that you can see. Basically, they represent the outliers which cannot be fitted in any of the quartiles. That's the beauty of this diagram, because it just shows you everything. In the case of class A, there is only one outlier, also not of much standard deviation. In class B, there are lots of outliers with low scores, even reaching 0. Now this is linked to the bell diagram that we discussed earlier on. Now you understand what this long left tail meant. Similarly, but in the opposite direction, class B, there are lots of outliers above the mean, even reaching 100%. Again, this explains the right long tail in the bell curve earlier on for that same class. Now you have mastered all the diagnostic tools required for descriptive statistics. You also know the exact pattern of your 3 classes. Time for you to make those calls and take action. Green light for class A, yellow light for class B, and red light for class C. At this point, you might be tempted to come up with various theories on why this pattern unfolded. That is beyond the scope of descriptive statistics. This is another very important diagnostic skill that you must master. That is to know at what point AI can't help. I hope that with this illustration, I've realized both how easy and hard it is to be a pilot in the age of autopilot, arena of statistics. Yes, your iPhone Pro Max can take the best shots with 0 skills, but you still need skills, the visionary and of telling the stories. The same for statistics in the era of AI.